Welcome to the lesson 10 video, interpreting graphs of proportional relationships. We're going to go ahead and start with example 1. Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Using this information, complete the chart. Okay, so I'm going to have an X column and a Y column. I'm going to call X flour because you need flour in order to make Y cookies. And according to our recipe, 3 cups of flour yields 4 dozen cookies. So then that means that 6 cups of flour will yield 8, just doubling it if you can see that. Hopefully you saw the pattern. If I double my recipe again, I'm going to yield 16 cookies. Okay. Is the number of cookies proportional to the amount of flour used? Explain why or why not. Well, one, you can see that I just doubled my recipe, but is there a consistent unit rate? Is there a constant of proportionality? Well, let's find out. If I do y over x, 4/3, it's going to equal 1 1/3 or 1.3 repeating. If I do 8 over 6, it's going to reduce to 4/3. If I do 16 over 12, once again, that reduces to also 4/3. So since I got a consistent unit rate, I can say yes, it is proportional. So go ahead and write this statement. Yes, because there exists a constant multiplied. I'm going to abbreviate that for space purposes. Corresponding measure of cookies. It's going to kind of cross over into the second box. Okay. All right. What is the unit rate of cookies to flour, y over x, and what is the meaning in the context of the problem? So we already discovered that the unit rate, which is k, is also equal to y over x, is 4/3, or 1 1/3, or 1.3 repeating. So we can say in the context, in other words, the setting of the story, 1 1/3 dozen cookies dozen calls for 1 cup of flour. All right, so let's go ahead and model the relationship. We're going to model the relationship on the graph. So we want to make sure you label your graph. We're going to call the x-axis flour and y-axis cookies. Okay. And I'm going to measure it. I'm going to move this down a little bit. I'm going to move this down here to flour. That way I have space to write my numbers. Okay. So let's create, I'm going to start here with 0 and skip a line for every number. All right. And then I'm going to do the same thing for my y-axis. Sorry for the beeping noise in the back. It's the PA system. Okay, so now I can go ahead and graph my points. So first set of points, according to my table, is 3, 4. So I'm going to go to 3 up to the point 4. Then I have the next set of points, 6, 8. So I'm going to go up to start at 6 and go all the way up to 8. All right, so I'm going to stop right there because that's the amount of space that my graph is going to let me go. You can go ahead and trace your line starting from your origin because this is a proportional relationship. As you can see, we had a constant. We had a constant of proportionality. So this is a proportional graph. Now, does the graph show the two quantities being proportional to each other? As I just said, the points appear on a line that passes through the origin. Now we can write an equation to represent the relationship. So our standard equation form is y equals kx. But particular to this problem, we're going to call it c equals kf. C for cookies and f for flowers. Flower, sorry. So, and we remember that k is equal to 4/3. So our formula is going to read as c equals 4/3 f. Okay, let's go on to example 2. Below is a graph modeling the amount of sugar required to make grandma's special chocolate chip cookies. Record the coordinates on the graph. What do these ordered pairs represent? Okay, so we have the ordered pairs 0, 0, as you can see, which is our origin, 2, 3, 4, 6, and these are all the plotted points here. And last but not least, 8, 12. Okay, now 0, 0 in this particular context, please pay attention to this, means that there for 0 cups of sugar, yields 0 cookies, 0 dozen cookies. Two cups of sugar yields 3 dozen cookies. Now, you notice that I've been saying dozen because this means dozen. This doesn't mean 5 cookies or 10 cookies. It means 5 dozen cookies, 10 dozen cookies. All right, so you can pause the video for right now and go ahead and do or write what these order pairs represent. I'll be looking for that when I check your folders. Now, grandma has 1 remaining cup of sugar. How many dozen cookies will she be able to make? Plot the point on the graph. So if grandma has 1 remaining cup of sugar, we have to figure out how many dozen cookies she can make. So this is 1 sugar. We're going to take our points, 3 over 2, just divide it by 2, and you'll get 3 halves. 3 halves, or 1.5. She will be able to make 1.5 or 1.5 dozen cookies. Or you can say, we know 1 dozen is 12 and half of 12 is 6. So that means 18 cookies. Now, how many dozen cookies can grandma make if she has no sugar? Can you graph this on the coordinate plane provided above? What do we call this point? Well, it's kind of already graphed for you, but if she has no sugar, as we said earlier, this point is called 0, 0. Okay, so we know that 0 cups of sugar will yield 0 dozen cookies. And we call this our origin. Okay, so this is the end of lesson 10 video. I would like for you to complete the exercise on page 41 and all the way up to page 43. Thank you.